Hi, this is Professor Poyo, and we are here to talk again a little bit about Chapter 10. We're going through Chapter 10, Section 3, and this deals with data analysis and statistics in the sense of measures of central tendency and variation. The example I have right here on this slide indicates a Glogster example of mean, median, mode, and range. And I just wanted to show you this very quickly to introduce you to this type of digital tool that you could use with your students. And basically what you're doing is creating a poster that is interactive. So let me show you what I'm talking about. This example right here has several hot links within it, and you can see it loading up right now. For instance, when you're talking about mean, you're looking for an average. So they have embedded, the author of this Glogster, this poster, has embedded some pictures here just to kind of give you an idea of what mean looks like. Same thing with median, mode, and also range. And range, when you're looking at taking the highest value and subtracting the lowest value, and that gives you what your range is. But we'll talk more about that. This is a great example. I love this picture of mode because I think it's real easy to see visually what the mode is, in the sense of which color do you see the most of. And the mode is what appears the most often, a value that appears the most often. So yep, that's an example of a Glogster, and you can actually create your own Glogsters if you'd like at any time. Now we see three of our academic language vocabulary words that we definitely need to know, and they are mean, median, and mode. All three of those should be familiar from previous educational experiences. Your mean is basically just your arithmetic average of a set of data. Your median is the value that sits right in the middle. And your mode is that value that occurs the most frequently. There are a couple of questions that I'd like you to try on your own in your textbook, page 651, number 1, A, B, and C. And the answers should be in the back of your book, so you can check those, but that'll give you some practice with mean, median, and mode. Again, what I'd like to show you is the difference between these three. When you talk about mean, you're going to add up all of your data and divide it by however many data values you have, or scores. Sometimes you'll hear it being referred to as a score. Once you divide it by that number, whatever answer you obtain is what your arithmetic average is. Now, when you look at median, you look for the value that sits right in the middle of a set of data. Now, the thing about median is that it doesn't necessarily represent the average, or it may not be your most appropriate example of finding what your average is of a data set. Additionally, I'd like you to recognize the fact that there are two different ways of computing your median. If you have an odd number of values, you look for the number that sits right in the middle. Right here, number 5 has 2 values to the left and 2 values to its right. So it is definitely right in the middle. That would be your median. However, if you have an even number of data, you'll notice here that you'll have 3 and 3, and so really your middle is these 2 data values that are right in the middle. So that once you circle them, you should have the same number of data values to the left of it and the same number to the right. That's how you determine the middle. However, that's still not an actual value, so you have to compute the average of those two numbers. So right here, 5 plus 7 divided by 2, your median for this set of data right here would be 6. Now the mode is that number value that occurs the most often, and sometimes it is significant in the sense of representing the average, but as you can see in this case, it definitely would not. There are 4 13s that appear in this data set, and all 4 of those 13s are actually the lowest data. So that doesn't necessarily represent the average, and we'll talk a little bit about that in a minute or two. Additionally, I've included here for you a YouTube video, and it's a song. It's pretty repetitive, but if it helps you to remember the difference between mean, median, and mode, then I would definitely encourage you to watch that video several times and perhaps memorize that song.
Hey diddle diddle, the median's the middle, you add and divide for the mean. The mode is the one that you see the most, and the range is the difference between. Yeah. Hey diddle diddle, the median's the middle, you add and divide for the mean. The mode is the one that you see the most, and the range is the difference between. Yeah. Hey diddle diddle, the median's the middle, you add and divide for the mean. The mode is the one that you see the most, and the range is the difference between. Yeah.
As I just mentioned, the mean, the median, and the mode are all measures of central tendency, but they may not all be the most appropriate average. Here are two examples, real-life examples, that we have to think about what value of central tendency, mean, median, or mode, would be the most appropriate to demonstrate the average or to represent the average. So you've got company Z, they employ 20 people. The president earns $200,000, the vice president earns $75,000, and the rest of the employees, which would be 18 employees, each earn $10,000. Now, is the mean the best number to choose to represent the average salary? Well, think about that. You may want to go ahead and calculate your mean. You have 200,000 plus 75,000 plus 18 times 10,000, and then divide it by 20, and what number do you get? And I think what I would do is ask myself, okay, if let's say we were going to hire you as a new employee, would it be fair to give you, our new employee, the average salary by calculating what the mean is? I don't know. You answer that. Another example would be 9 students make the following scores on a test, and here they are listed: 30, 35, 40, 40, 92, 93, 98, and 99. Now, if you chose the median, which would be that value that sits right in the middle of those scores as they are arranged from least to greatest, would that be the best average to represent that set of scores? Think about that, and then once you have an answer, I want you to turn to your page 635 in your textbook and look at the examples they've given you there. These are both taken from that book, and the answers are written in there. They give a brief explanation of what they would choose. Okay, the next section that we're going to talk about is measure of spread. As you can see, there's several academic language vocabulary that we need to look at. Range, median, lower quartile, upper quartile, inner quartile, and outliers. Now this is where we start getting into box plots and whiskers. If you've never heard of those before, they're in your textbook, and we're going to talk about it in the next few slides. So I want you to understand the difference between all of these. The range obviously is your difference between your greatest and least values. Your median is what we would consider Q2, or the middle 50%. The lower quartile would be Q1, which is the median of the lower half of the scores. The upper quartile, which is Q3, is the median of your upper half of the scores. And then your IQR, or your interquartile range, is the range basically taking your Q3 and subtract your Q1. So it's that inner range of your middle half of the data. The other concept we're going to talk about is outliers, and there is a formula that you can use to determine whether or not there is a specific piece of data or value or score that doesn't even come close to the rest of the group's scores. If it's so far out that we would consider it an outlier, then we would use this formula. Okay, I would like for you to look in your textbook at page 637, and you will see these vocabulary terms and look at the figure 10.7 and see whether or not you can identify these vocabulary words in the example that they've given you. Okay, here's your examples. or here's your example and the answers. So if you haven't figured it out yet, then I would say go back and pause the video and see if you can figure out which values would be considered the range. And one of the things I want you to recognize in your textbook, you can see that the way they drew their box plot is by starting with a number line. And that number line is drawn so that the box plot hovers above the actual number line. And I'll show you an example of that in a second. Here you go. See how it hovers above that number line, but make sure that the number line is marked so that you know what each of those ticks stand for. Now notice that the very least value, your lowest value of your data, is the very first point, is the end of that first whisker. And then the next point that you would actually plot on this as you're creating a box plot is right here. And this would indicate your Q1. All right. This right here is your Q2, which is your median. And this right here is your Q3. Now, sometimes a line is drawn above. See how it's closer to the top of your rectangular box? Oftentimes you'll see it drawn right here in the middle. Either way is fine, it doesn't matter. And then your highest value is the end of that second whisker. So this whole thing is considered a box plot with whiskers. These are the whiskers. That's the whisker, that's the whisker right there. All right, and basically what a box plot does is gives you a visual display of your data in the form of a box plot. And so you can see how far away from the middle, the median, is your lowest value and your highest value. So there's a lot you can interpret from box plots, and again, you know, we'll talk a little bit about that in class, but there's also information in your book. You are more than welcome to Google box plots and whiskers, and you can gain more information in that respect as well. So we're going to practice now. Here are Mrs. Plum's class test scores. Notice that the very first thing that you have to do is arrange them in order. Always, always. From least to greatest. Okay, so when we arrange them in this way, we can see what our highest value is. Okay, right here, 98 is our highest value. What's our lowest value or our least value? Right here. Now, if you remember, the range is obtained by taking your highest value and subtracting your lowest value. Your median is that score that sits right smack in the middle. So we would count up the scores and find out whether or not it's an odd number or even number. If it's an odd number of scores, you will have one data value that is exactly in the middle. However, if you have an even number of data, you take the two that are in the middle, add them and divide by 2, and that will give you your median. Now in this case, our median is right in between these two, the 84 and 84. So I would draw a line right between them if I were you. And in order to determine your lower quartile and your upper quartile, or your Q1 and your Q3, you disregard these two numbers in the middle. And you just look at these values right here for Q1, and then all of these values for your Q3. So let's look down here at Q1. How do we do this? Same exact way that we found what our median was. Just with these values, all right, so from 84, all of this area, to 51. Find the middle, and again, it's going to be an even number of values, so you're going to have to take the two that are in the middle, add them, and divide by 2. So it's the average of the two values that fall right in the middle. That's your lower quartile, or your Q1. With your upper quartile, you're going to do the same thing, only you're going to start with this 84. Wait, hold on. Yep, this 84 and 98. Go all through this. Find the two values in the middle, add them, find the average, so you divide by 2, and that's your upper quartile. And in order to find your interquartile range, we will look at that on the next slide. So try as best you can to get these answers, and your next slide actually has your answers. Okay, so here's this test scores. That's what we want, our range, median, lower quartile, upper quartile. And then here, in order to get our interquartile range, we look at Q3 and we subtract Q1 from it. So it's very similar to what your range would be in the sense of taking your highest value, subtract your lowest value. But for your interquartile range, you're just looking at the values in between your Q1 and Q3. Okay, and then for your outliers, you're going to take your Q3 minus your Q1, multiply it by 1.5, and then add it to Q3 or subtract it from Q1. Okay, I'm going to go ahead and show you the answer, so if you don't have your answers yet for this, just pause the video. Otherwise, here they are. Okay, now when we're looking at the outliers, notice over here that what we wanted to do was to take our Q3 and add the IQR times 1.5, which was 36.75, add it to our Q3 and subtract it from our Q1. Now notice when we add it, there are no scores that are 127.75 or greater. So there's no outliers on the upper end, and at the lower end there are no outliers either, because what 66.5 minus 36.75 is 29.75. Well, we can see right here that there's no scores that are that low. So in this example there are no outliers. All right, for this slide, what I'd like you to do is, if you are feeling excited about using your calculator in order to create a box and whiskers, you may use this YouTube that I have embedded in the PowerPoint. So go ahead and either use the PowerPoint from My Franciscan or, yeah, that's what I would do, is just do it that way, because right now we don't have enough time for me to go ahead and click on it here. But there's your link, and it'll actually show you how to create a box and whiskers on your calculator with a TI-83 or a TI-84. And the other thing I want you to notice is how you can use box plots to help you compare distributions, to compare medians, and to compare extreme scores. Again, I'd like to refer you back to your textbook for this one, page 641. They do have an example there, and there's a good explanation, in my opinion, of what it is that you are looking for when you see two box plots that are next to each other. Now, additionally, there is another box plot on page 642 in your book, and it is an actual school page that's embedded in your textbook, and I'd like you to use the scores, the data that they give you there, and go ahead and try to create your own box plot and whiskers using the information you've gained from this tutorial.